LiveStore is a client-centric, local-first data layer for high-performance applications. I'm thrilled to be the first to tell you more about it, how LiveStore works, and how you can integrate it with Expo to build powerful, local-first native apps. In this video, I'll cover a quick intro to local first for those who don't know. Then we'll dive into LiveStore details and how it works internally with and without a sync engine. Finally, I'll show you a demo app that I really enjoy building myself, showcasing some of the advantages and benefits of building local first apps, as well as the powerful LiveStore DevTools for debugging and testing. So what is local first? The term local first was first coined in the paper Local First Software by the research lab Ink and Switch, but the ideas behind it have been around for a long time. It's the architecture that powers some of our favorite apps like Linear, Superhuman, SQLite Draw, and Apple Notes. And according to Martin Kleppmann, one of the authors of the Local First paper, in Local First software, the availability of another computer should never prevent you from working. In other words, when you're offline, you can still read and write directly from a database, and you know that when you are connected to the internet, your data will be seamlessly synced and available on any of your devices running the app. When you are online, local first architecture is well suited for multiplayer apps as popularized by Figma. And here we have a screenshot showing the collaboration that you can achieve using a local first architecture. Now, you might be wondering, is it difficult to build local first application? Well, that's a great question. Building a local first app isn't exactly straightforward. It involves creating a seamless offline experience. That means we need offline support, which typically requires a database on the device itself. But then, how do we store data in a database and update the UI in real time when the user makes changes? On top of that, we need to think carefully about how the data is stored, especially if we want to sync with other devices. This requires a robust data structure, one that is flexible enough to support adding fields and scaling as the app grows. It can quickly feel overwhelming for developers managing offline support, real-time updates, and data syncing, all while keeping the app scalable. But that's exactly where LiveStore steps in. LiveStore is developed by Johannes Schickling, who in the past also founded Prisma and is now building Overtone, a modern local-first music app that uses LiveStore. He has dedicated years of research into local first, and LiveStore is the result of that work. He's also the host of Local First FM podcast, which I highly recommend listening to. So what can LiveStore do for you? Reactive and persistent SQLite. Like I mentioned before, when building a local first app, you need to update the UI, save into a local database, and keep a sync and the app very responsive. So LiveStore makes that very easy, and you'll see how in a moment. It's also very high performance. TypeScript is a must-have nowadays and makes developers more productive. LiveStore comes with a powerful type-safe schema, premium developer experience, and DevTools. Let's see how LiveStore works. As you can see here, we are importing two hooks, useQuery and useStore. So you can simply define a query by typing a plain SQLite query, like for example, select all from to-dos. And then once you have this query, you can use it with the useQuery, passing the query as parameter, and voila, you have the to-dos and you can start displaying them on screen. If we start adding more items to the database or to the app, this query is going to be updating the results on screen. So we don't need to do anything else. Now in this example, we are not typing the query, but we can also do that, and I'll show you how in a moment. Another thing to notice here is that everything is going to be stored on the file system of the device. We will be storing everything on a database, but on top of that, we will have an extra database that is going to be storing the event history. The event history is useful for regenerating the same state of the application, and this is useful when we are syncing. Also, by the way, we have a to-do component at the bottom, and this to-do, it's showcasing how we can do a mutation. To create a mutation, we can simply grab the store using the hook useStore and then call mutate. And then from our mutations, we can call the complete to-do, passing the to-do ID as parameter. Once we update a to-do, this will also trigger a re-render on the to-dos query, or the component that is rendering the list of to-dos. And then every single change that we are doing is going to be stored in the event history database, as well in the database that is stored in the device. Now let's see how this would look once we connect a sync engine backend. So in this case, we have client A, B, and C. So in the client, everything is going to remain pretty much the same, but the sync engine is going to be using the event history to track the changes and sync this state across multiple clients. So client A, B, and C will work the same, will be communicating with the sync engine, and the sync engine is going to be in charge of resolving and updating the state and then sync that back to the client so that everyone has the same state. Now it's worth mentioning that in this example, I won't be covering having a sync engine because it's still a work in progress, but as soon as it's ready, you can count that I'll be creating a new video. All right, now I think we're ready to jump into the demo. All right, so finally we made it to the demo. And as you can see here on the right, I have this linear mobile app. So let's go ahead and open it. Okay, and here we have the app. So the first state that we can see it's going to be empty. But if I go to my second screen, I can start generating some data. So in this case, I will generate 5 users and assign 10 users to each of them, as well as 50 issues for Beto. So let's come back. And just like that, we have 100 items super quickly, and they are showing on screen. Now, let's just see what we can do here. We can go to the Created tab, Assign tab, and also we can apply some filters, which is really cool. By the way, this is compatible with dark mode, which is really nice. And we can also navigate to each item and even edit some stuff. So this is the app, this is how it looks, and it's using LiveStore. One thing that I really want you guys to notice is that each time that I'm switching between tabs or opening this and start filtering issues by user, priority, all this is being fetched directly from the database. Now, if I go ahead and reload the application, since we already have data, we're going to see that everything appears very quickly. Now, typically in local first apps, you'll notice a loading state, often a long one, the first time that you open the app. This occurs because on the initial load, the entire user data is downloaded. However, once the data is stored locally, you won't see a loading spinner again. That's why when I switch between assigned or created, the queries are very fast because we already have the data and we are just querying directly from a local database. All right, so the first thing that I want to show you is going to be the schema. So when we're using LiveStore, we need to define a schema. And the way we do that is by importing the schema and make schema from LiveStore. This is how it looks. I will show you just these tables that I think are simpler to understand, and then maybe we can show the ones above. In this case, I have a user table. We can define just by saying dbschema.table, the name of the table, and the structure of this table. As I mentioned previously, this is going to be fully typed, so we need to define the type of data of each item. In this case, ID, name, email, all these are going to be text. But for each property, we can define some things like the primary key, or if this value is going to be nullable, or maybe you can also want to define a default value. You can do that as well. Here we have the issues table, and it's very similar, very straightforward. In this case, we're using some integers for the deleted at and created at. So fairly simple. And if I scroll all the way down, we are exporting the type of each one of these tables. So in this case, I have all these tables. I'm exporting that so that I can use it across my application. Then if I keep scrolling down, I'm basically creating an object that contains all the tables. And then we call this make schema function, passing the tables, mutations, and the migration strategy. So let's see how the mutations look. On the left, inside my schema folder, I have a user mutations. And this is great because we can decouple into multiple files all the mutations that we're going to be using across our application. In this case, I'm defining a create user. I also have a delete user. And as you can see, we're using just plain SQLite for inserting users, passing parameters and values. And we are defining the type of data that we are going to get when we are creating a user. And we're using effect for typing the parameters. This is how we can delete a user. We pass the name of the mutation. We defined the structure. So to delete a user, we just need the ID so that we can identify the user. And then we delete it from the users table. So once we have our mutations defined, we can come back to the schema and pass the mutations in here, and that's it. Then we can use the schema. By the way, notice that I'm also exporting the mutations from this file. Now the next step is going to be the entry point of your application. So if I go to my layout and scroll down, you can see that I'm using a LiveStore provider. This is necessary so that we have access to all the queries and store across the application. This provider needs to have the schema, and it also comes with really cool properties like render loading, which actually gets the progress of the loading stage. So I'm just rendering the state based on what we have in here. And then we also have this render error, which is great. If we have an issue, we are going to get that on screen, and I'm just displaying it as it is. Now, render shutdown, it's a property that also gets a component, and this is going to be called mostly when we are using the LiveStore devtools, and we're going to see an example in a moment. But basically, the only thing that this is doing is triggering every render so that we refresh the application and the store. Now, we also have an adapter. This adapter is necessary for the devtools. Batch updates, it's coming from React Native, and it's actually an unstable property. Another important thing that I want to notice, and I think it's really cool, is that we have this boot property. And if I come down here and look at this function, this boot property, it's going to be called the first time that we load the app. And this is great because this is the time to initialize the database, and we can use this function to cleanly do that. So in this case, I'm just checking first if we have some to-dos, and I'm also checking if we have some users. And if we don't have any users, then I'll go ahead and call store mutate. And from my mutations, I'm using the create user. Everything is going to be fully typed, and I can just go ahead and type name so that you can see that we get autocomplete because the mutation is fully typed as well. So that's why the first time that I log in into my application, I have a user always. And if you're going to play around with this example, you can come here and switch the user. Now, before I jumped into the queries, I want to say that the mutation definitions can be removed after they were added to your application. And mutation schema definitions can be evolved as long as the changes are forward compatible, which means you cannot delete, for example, the name, right? If you already have data, you can simply come here and add more items, but deleting items is going to cause some issues. And also the new items that you add need to be optional because the previous items that we had before didn't have these values. Okay, just something to keep in mind. Let's go ahead and see how we can query data. So to show you the queries, I'll go to the edit issue, which basically what we're doing here is once we press on an item, we are navigating to this edit issue screen, but we are passing the issue ID as parameter, and we are fetching these details and comments from this issue right on the screen. So I'm using this query, and this is how you can structure or create queries using LiveStore. Basically, we use the query SQL that comes from LiveStore, and then we pass our plain SQLite syntax. So in this case, I'm passing the issue ID as parameter. Then we define the schema. So in this case, I'm using effect, and this is pretty powerful because this is going to return an array of issues. So what I'm doing here is just typing this as an array with the type of the issues. So this is how it looks. And then I'm just getting the first item using the head or less schema. And these schema methods are coming from effect. And if you want to learn more about effect, you can just go to their documentation. And in this case, I'm memoizing this query. And every time that the issue ID changes, we're going to generate again this query with new parameters, of course. Then we can use this query with the hook use scope query, or we can also use the use query hook as we mentioned on the example. I can just type, for example, issue dot, and you see that I have access to all the properties fully typed, which is great. So let's go ahead and delete that. Now, just to show you, down here in the component, we can simply access the properties to display them on screen. And this is what I'm doing in here. Now let's go ahead and switch to light mode. And let's go back to the home screen. I want to mention that we can also create very complex queries that, for example, in this case, use the case, right? So this is like an advanced feature of SQLite, which evaluates a set of conditions, and it's like having an if statement right into your query. So you don't have to have any JavaScript. This is directly being handled in the SQLite level. And I'm using this powerful feature for grouping elements. So when I come to my application and start filtering, for example, by priority or by status, and go back to the created and then start by status as well, or assignee, you can see that everything is being changed in real time every time that I switch these properties. I can show the priority, I can only show maybe the text or show everything, and everything is being handled by the same query. So all this complexity that you can see here, it's changing each time that I switch between these two tabs, assign and created. So once we have this piece of the query, because that's only a piece of the query, I can come down here where I'm using my issues query. This is like the very complex query that it's actually using a left join on top of my get ordering options, passing the current tab, the current ordering that the user wants, and I'm, forming this very complex query with a left join, selecting items from the users table as well as the issues table. And on top of that, I'm saying that I just want to show items that are not deleted. And you might be wondering, why would you have this validation, right? So when you are dealing with local first applications, it's not recommended deleting items because this can cause issues when we are syncing data on the sync engine. And also it's a good practice to allow user to undo things, right? So in this case, by the way, if I come here, sorry, I got a bit distracted, but if I come here and delete this issue, you can see that it says deleted and then the date. So that means that I won't see this issue in my home screen, but the issue still exists. The only difference is that it's deleted. And maybe I did that by accident, so I can undo and delete again. So this is great. And we can still have this issue in memory for a long period of time, and then maybe a year later now delete it. So doing this, I think it's a good practice, and actually you can see it on the real Linear app. When you delete something, it's actually still there, but it's just deleted, and you can restore everything, which is a good feature. Now, to finish talking about the queries, I just want to say that if you notice across the entire application, for example, when I switch between tabs or when I filter something, everything is being handled by LiveStore directly. So I'm not using use state, and it's actually recommended to not distinguish between the app state and the app data, but rather keep it all on LiveStore. This unlocks many possibilities, and actually I want to show you now. For example, if I come here and start editing this handling thing, and let's say that I didn't press the done button and I just dismiss. So the change, because I'm handling even the text input with LiveStore, every time that I change something, it's going to update the database. So I don't need to care about the state of the input. I can just simply say, if the user types something, just put it on the database. We can extend this to inputs, filtering settings, user settings, and even navigation. And this is really cool. So for example, let's say that I was typing something here, like hello, and then somehow, I don't know, my app died or my phone died. And if I reload the application, you can see that we are going to restore where we left at. And not just reloading here, but if I just go ahead and close the entire application and come back to the app, it's going to take me where I was. Okay, and if we wait for a second, you can see that I get back to where I was. This is huge. I think this is a better user experience. And for example, let's say that you were writing something very important here and just dismiss, everything is going to be in here right away. Now, in some cases, if you prefer, like tracking the, I don't know, mouse position or tracking the input state, it can make sense to keep the version of the state outside of LiveStore, but in most cases, I would recommend to just use LiveStore for everything. Now, on top of that, let's say that the user was typing something here and then it switches devices. If we were to have a sync engine, he can just open the app on an Android device, for example, and it's going to be taken to the exact same screen with the same input, and the user can continue working on the same issue in this case. Now, just as a final note, for queries that return many rows, it's recommended to use pagination, usually both via paginated and virtualized rendering as well as paginated queries. Okay, so now we learned how to create a schema, how to mutate data, how to create mutations, how to use queries. Now let's see the fun part, in my opinion, which is using the devtools. So the devtools honestly are my favorite part because it makes developing LiveStore applications very easy. So to open the devtools, we can simply go to the terminal and press Shift M, as you can see here in the shortcut as well. This will show you this menu, and at the bottom, you can see Open LiveStore DevTools Expo. So if I press Enter, this is going to open a new window, and this is how LiveStore DevTools look like. So on the left, I have all my tables. So as you can see, I have almost 500 comments, issues, reactions, and I can quickly click on each one of them and see all the data that I created previously. On top of exploring data and actually being able to update the data, we can simply come here and update the value, which is really cool. I'll do that in a moment. I want to also talk a little bit about the live queries. This tab is going to show you active queries that our application is using. So for example, the query that I'm using that is not being unmounted, it's one that is user count. So the user count, for example, even if I go to another screen, this query is going to be listening for new events. So if I go ahead and delete an issue, now it's going to change to 98. Even if I'm not in the home screen, this is going to be updated. This is useful sometimes, or otherwise you can use scoped query if you don't want to be listening to these changes. But as soon as I change to the created tab, you can see that we are not using anymore the issues assigned query. But if I go to the created, now we are using issues created query, and it's showing the data. And this is going to be preserved as well. So for example, if I leave my application on the created at and reload, in the created tab and reload, once we come back to application, we should be on the created at, as you can see there. DevTools also show you the slow queries. So in this case, we don't have any slow query, but this is great for debugging, especially if you are dealing with a bunch of data. You can come here and see which queries are taking so long, and maybe you can consider using pagination or any other optimizations. Now I want to show you something really cool. So instead of deleting everything from the app manually, it's very useful if we just go to the General tab, and from here we can say Reset All Data and call Resets. Now we get the state where LiveStore shut down and we can reload. Now, which makes this kind of approach very amazing is that we can actually just import a database directly to the device. And in this case, for example, if I come here, click on the import DB. So I hope you can see there, but I have two databases. And this database I created previously. So it has, I think, 3 or 4 issues. So let's go ahead and open this database. Now, on the right, you can see that LiveStore shut down, and I can just press reload. And suddenly I have the same state on my application. I think this feature is huge. Have you ever struggled to reproduce an issue? Well, that's no longer a problem because you can simply load the entire user database and recreate the exact state they were experiencing. Now you can also do this manually. Now to show you how this will work on a different device, let's just go ahead and create some data here. And we have 50 issues now on the iPhone SE. And this is coming directly from the simulator, so I can just come here and delete these databases. And if I reload, the data should be gone. Okay, the data is gone, but these two databases are recreated. So if you want to do this manually to, just drag and drop a database that you already have, in this case, I already have these two, which these two contain the state of the iPhone 16 Pro, I can simply just copy the LiveStore here and come here, paste it in here, and just rename it. So I'll just rename with this name and delete this one, rename. And you can do the same with the mutation log if you want. But at this point, I can just come here and reload the device, and it should be able to grab the state from the new database. So now we effectively have the same state in both devices. So we can do that from the file system, or it's very easy if you do it directly from the DevTools. All right, so I'll close this iPhone SE and let's go ahead and reload. I also want to show you guys the mutation log. So this tab will show you everything, and this is actually a pretty good understanding to see how everything, every single detail, it's being stored in LiveStore. So when I switch something, when I changed a text, and you can see here, when I was creating the demo time issue, each time that I pressed a key or I typed a letter, a new event was created on the mutation log. And this log can be quite extensive since queries are triggered by user actions, such as typing input fields, navigating to a new screen, or applying a filter. Another cool thing, by the way, is that we can quickly come here to the data browser, select the issues tab, and if we scroll to the right, I can change this status to be in progress. And as soon as I press enter, although this is changing directly the database, my application is updating, and I can do the same for any item. So as soon as I press enter, the updated data is being reflected on the simulator. Now that we are here, we can also come here to the app, and the app is the table that I'm using to store user preferences. So for example, if I come here and switch the selected tab to be created and hit enter, you can see that basically I can control the application. If I keep scrolling down, you can see that I can play with what I want to show. So in this case, I'm on the created tab, but let's come here and switch to the assigned. Hit enter. Okay, and let's come here and we can play around if we want to show or not. This is great. Even imagine if we already had the sync engine and I want to educate my user, so I can say, oh, you can assign or press here and press there. Or if you want to navigate to a specific screen, you can come here and switch the navigation. So for example, if I want to navigate the user to the inbox, I press enter. Now, in this case, I would need to reload the app because I'm only checking the navigation once we load the app for the first time, but it's going to take me to the inbox. And let's also say that we want to take the user the next time that he opens the app to the settings screen. So we can say filter, settings, and hit enter. And now the next time that the user reloads the application, we open the filter settings. And from here, we can do everything. I think this is very powerful and can allow developers to ship quickly. We also have signals. Signals, it's great to check how many updates and how many times we have used a query. So for example, and we can also get real-time updates in here. So if I come to the app and start moving around, you can see that some of the things are being highlighted. This stuff is an excellent tool for tracking performance and memory leaks. It displays number of updates for each query and updates dynamically as you use the application. We also have this SQLite tab. So basically we have everything on the DevTools. And from here we can use the app database to start running queries. So for example, if I run this one, you can see that I'll get all the data that we have on the application. And you can play around with this query before you can start integrating it in the code. So this and many more things that are coming to developer tools that I'm super excited about, and allows for many use cases like storing the text input, the navigation, and also replicating the exact same state from other devices using the database. And that brings us to the end of this video on LiveStore, a client-centric local-first data layer for high-performance application. I hope you now have a better understanding of what makes local-first architecture so powerful and how LiveStore enables you to build robust, high-performance native apps with ease. To recap, we explored the key concepts of local-first, we dive into how LiveStore works internally, and finally, we wrapped up with a demo showcasing the advantages of building a local-first application and how the LiveStore DevTools make debugging and testing a seamless experience. Thank you for joining me on this journey. I'm excited to see how you use LiveStore to build your own apps. If you have any questions, feel free to reach out or check out the documentation to dive even deeper. Don't forget to like, share, and subscribe for more videos like this. Until next time, happy coding!